Okay, guys, since we're not able to be in class, I thought we'd go ahead and do a few examples together. Well, I'll do a few examples so that you can see how these problems are worked. Some of you are going to have some questions about the working, so I wanted to make sure that you had all the resources that we could possibly give. So let's just look at some of the examples from the exercises. So looking first, just using the general rule for the geometric sequence, remember that the rule is simply any term can be found by taking the first term times the common ratio to the n minus 1, where of course n is the number term you're looking for. So in this particular case, they wanted, here's our rule. The first term is 6 and the common ratio is 2. So from that we can derive a formula, and we're looking for the 7th term. So the 7th term is simply equal to our first term times our common ratio of 2 raised to the n, which was 7 minus 1. So 6 times 2, and 7 minus 1, of course, is the 6th power. Raising 2 to the 6th power, then multiplying it by 6 gives you 384. So very straightforward. The math is all in your calculator, so easy to work with there. Right? Now, next, let's look at an example where we're having to actually find the rule, use the rule to determine the value of the 8th term of the geometric sequence, and then they give you the geometric sequence. So what we have to do is we have to find our A and our... So first we need to find A and find R, our common ratio. Now remember that finding A is easy. It's just the first thing at the first term of the sequence. So A in this case is 100, the first number in the sequence. To find R, that's also very easy because remember it's a common ratio. So we're just going to divide. And so remember we divide the second term by the first term, and that should tell us. And they've told us that this is a geometric sequence, so we're pretty safe in just assuming that. So our second term is 50. If we divide that by our first term of 100, we're going to get an R of 0.5, or 1/2 if you prefer. It doesn't make the slightest bit of difference. So substituting that into our rule, we get any term in this particular sequence can be found by taking 100 times 0.5 to the n minus 1. Now, they want us to find the 8th term, so we'll do that with 8. And so that means t to the 8th, is t sub 8 is 100 times 0.5 to the 8 minus 1. So 0.5 to the 7th power. And then when you put that in your calculator, you can see the answer they got, a tiny little decimal. So this is an example of geometric decay. It's going down in value. Okay. Let's look at the next thing they do to us. Example 20. This is a good one because they're going to give us, they want us to find 2 terms, but they don't give us all of the values in the sequence. So in this case, we have 2 equations that we have to deal with here, which means that we're going to be working with simultaneous equations. Okay? So, substituting t to 4 equals 24 in t to the n equals, so the formula where the n equals 4. So that gives our first one. So we know the value of the 4th term, and we know that it's going to be 4 minus 1 because it is the 4th term, right? So that gives us the first equation. I know it's crammed across the edge here, but you can see that. So 24 equals a to the r minus 4, so that gives us 24 equals AR to the third power. Now the second one says the ninth term is 768. So again, substituting that in, 768 equals AR, and the ninth term, so that's 9 minus 1, gives the AR to the 8th power. And now what I can do is I can solve those simultaneously. Now again, this time your A and your R are connected by multiplication. So the only way to get rid of it is to divide one of the equations by the other equation. And since these terms are bigger than the others, we'll do that one on top. So 768 equals AR to the 8th divided by the whole equation, 24 equals AR to the third. And right away, anything that's divided by itself is going to divide away. So that's going to divide out our R term, which is good. 768 divided by 24 is 32. And R to the 8th divided by R to the third, remember that when you're dividing with exponents or indices, you subtract them. So that's R to the 8 minus 3, so R to the 5th. Then what we need to do is get rid of this exponent, and the opposite of an exponent is a radical, or a root, or a surd, whichever word you use. So we're going to take the 5th root, not of one side, but of both sides. Now don't worry too much, your calculator can do this math for you. These are going to eliminate each other on this side and leave you just plain old R. And the 5th root of 32 is 2. So we end up with R equals 2. Now, let me assure you that R is always going to be 2 or 3 at the most, because if it gets any bigger, then, well, it just becomes insane. But now that we know what R is, we can substitute it into either one of those equations and find our A. Now, of course, it's going to be easier to use the smaller numbers, so let's just use that. So we have 24 equals A times R. Now, be careful when you do this. So our R is 2. We're going to substitute that, times 2. And, of course, that's raised to the third power. So that gives us 24 equals A. 2 to the third power is 2 times 2 times 2, so 8. So that makes 8A. That's 8 times A. The opposite of multiply, of course, is divide. So we'll divide both sides by 8, which gives us A of 3. So the very first term in this sequence is 3. Okay, so a little bit different working over here. You've got to use a lot of your algebra skills from the past, but it's very straightforward algebra. Just pay attention to how things are put together and think about using the opposite in order to be able to get rid of them. So in this case, I had to divide the two equations because the A was I wanted to eliminate, and since it was connected with multiplication, I couldn't use addition or subtraction to eliminate it. Okay. Let's see. The next example, they want to see how long it takes to get to a certain number. Now, this one is really more about just using your calculator and doing some guessing. You're just going to be doing some trial and error for this. So when we're working with these, thinking about these numbers, just move this up a bit so that you can see these. So how many terms do we have to write down in the geometric sequence, blah, 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 before we find a term greater than 1 million? So the first thing is we have to find the A and the R. And you see that the first term, of course, is 0.5. And if you take 5 divided by 0.5 to find the common ratio, you're going to get 10. And that gives us the general rule for the sequence. So here's our general rule. And they want this side to be bigger than 1 million, because we're looking for a number that's till we get something that's bigger than 1 million. So what we're going to do is we're going to solve the equation, and then so that we get the exponential term all by itself, and then we're just going to try some numbers and see what works. But you've got to be careful when you do that. So let me show you what I mean. So we have 0.5 times 10 to the n minus 1 is greater than 1 million. Now, here's our unknown, our n. So I need to get that n part by itself. And since it's connected to the 0.5 with multiplication, we'll take it apart with division. So again, if you can identify how things are put together, then you know how to take them apart. And if you can identify what your unknown is, then it's very easy to know what you have to move. So those are going to divide away. And when you divide 1 million by 0.5, okay, you're just taking it, you're just making it, dividing it in half, right? So we get some 10 to the n minus 1. Okay? I'm sorry, we're dividing by, we're going to double it, sorry, because we're dividing by a smaller number than 1. So when you double that, you're going to get 10 to the n minus 1 equals 2 million. Okay? Now, then you just need to find out what number would equal that value. So you need an n minus 1 that will give you a value bigger than your number. So by trial and error, if you just look in your notes there, you'll see that in order to get a number bigger than 2 million, you're going to have an n that's greater than 7, and greater than 7 means at least 8. So that means you would have to have at least 8 terms to find the first term that exceeds 1 million. So get the n all by itself, and then just start thinking about numbers that would give you an exponent greater than. So just use your calculator. Right? And then, of course, graphing a geometric sequence. Remember that you're just going to find some values, find a table of values, and plot those. And if the numbers are going up, you're going to get that exponential curve going up. If the numbers are going down, you're going to get the exponential curve going down. Okay? So hopefully that'll help you out with your homework. If you need help, pay particular attention to that one where you're solving these using the simultaneous equations, because that seems to me like it would be a good one for the unfamiliar situation. Thanks.